see my
Yes, yes, yes.
Yeah. Okay. Okay, Praveen, can you give me the brief introduction of yourself?
My name is Praveen Kumar Yadav. I am doing MSY research in VLSI design, and uh, I have I have got CGPA 7.56 in, like, right now I am the placement coordinator for electrical for MS students, and uh, I was in the Vidyuti club, that is for the electrical club in our college. I right now I am also in the like analog and circuit head in that group, college group, that is Vidyuti club.
Okay, so which languages you know?
Like I know Verilog, System Verilog, and C and C++, MATLAB, Python.
Okay. So I want you to like make what you to hello.
Yes, ma'am. Okay.
Please one by one. Okay, let's start with Praveen. What do you understand by the FSMs?
FSM, like it, we whenever we need to make any complex circuits, then we need FSM to minimize complexity of that architecture. Like it can be uh, uh, mainly it reduce the complexity of the structure. Like I did in the FFT, 512 FFT, I made one project. In that, it was difficult to make all stages 9 layers. For 512, we need 9 layers, butterfly layers we need. So that was now that was getting very difficult. So I just use for loop and corresponding whatever stage I need to, that I made on FSM, so that uh, complex structure reduced to very simple code.
Okay, Hari, can you explain the FSMs?
Regarding the FSM,
You're not audible, I think.
hello ma'am, am I audible?
Praveen, are you able to listen, Hari?
Very low voice.
Yeah, okay. Same for me.
Ma'am, are you able to hear me now? Hello?
Yes,
No,
totally.
no, no, clear.
Okay, okay ma'am. Yeah. Regarding FSMs, if you want to know the if you want to know the process of any complex any complex designs, and it demands to know the states of the those complex designs, we understand we should know about FSM states, ma'am. And now, why exactly FSM means? Well, let's say, let's consider let's consider a practical example. Let's consider a coffee machine, and if we want to have a cup of coffee, we should press the we should press somewhat button in that machine, and after after we got whatever we want, that particular device should go into the reset state. In those uh, in those complex designs, we should consider FSM states, ma'am. And there are two types of states, melee FSM, sorry, there are two types of FSMs, melee FSM and Moore FSM, and both having their own priority and both having their own pros and cons.
Okay.
Should I continue or we can?
That's all, or you have anything else
Uh,
to?
yeah, and we should consider these FSMs in protocols like UART, SP, and I2C, and we should also consider these in complex designs, of course, like protocols, and in even in asynchronous T4 we consider the FSM, ma'am. Um, yes, ma'am. If we want our device to be in to be ideal state, we will consider it in ideal state according to our code given. So this is all about FSM.
Okay, that's fine. Okay, in the chat box, I have written the question. Please solve it.
Okay. Very log, ma'am.
Yes, yes.
Okay.
So you can just write in a notebook or on the word pad as you are comfortable, and you can just click here the new chat and give to me personally chat personal chat. Okay. Hello. Hello, am I audible?
Yes, ma'am. Yes, ma'am.
So you can if you are when you are done, you can just ping me on a personal chat here in the Zoom.
Okay. Okay. Hello, ma'am. Hello.
Yes.
Should I show or
Can you just give the no. You can just take a photo and give it to the private of this Zoom meeting. What?
I have written it in a notebook, ma'am. Notebook.
So you can click it picture and send it to the WhatsApp and copy it in here chat only.
Okay. Okay.
Uh,
Hello, ma'am.
Yes.
Yes, ma'am. After that, it will be end and end module, ma'am. I want to write that in the whole paper. That's why I have written in single page, ma'am. If you want to rewrite me again, I can write that in second
No,
page.
no, that's fine.
D out is data out, ma'am. I have given output as data out, and in between I have written as D out.
Can you like explain me every state, like for input zero we have what where we have to go, and for input one where we have to go
Yeah, okay, ma'am.
according to your diagram? Yeah.
Okay, ma'am. Actually, the given one is 11011, ma'am. Mure.
Yeah.
Mure output depends on only present state, ma'am, not inputs. So the state itself, I have provided the outputs, ma'am, that you can see in the diagram. FSM. And
Yeah.
for me, if reset is high, my data should be zero, and the state will be in ideal state, ma'am. That is S0 in my code. And if my data in is high, it should go to S1, and still the data out is zero because my output was not equal to 11011. So my data
Yeah.
out is zero, and accordingly it will go to S2, ma'am. The same scenario happens applies for S1. If my data input is high, it will go to S2, or else it will stay in the S1, ma'am. Sorry, or else it will go to S0, because if zero, it is in the reset state, that is ideal position, that is S0. Um, and if my data in is low, it goes to S3, ma'am. At last, if my data in is after S4, if my data in is high, it will go to
Okay,
S5.
okay, wait. Don't you think for S2 state, when the input will be 1, it should go to the S2 only?
It will go to one. If the data in is low, it will go to S3, ma'am. Yeah, yeah.
Okay.
And if data in is high, it will remain in the S2 itself.
Yeah, okay. Proceed.
After that, if my in S3 state, if my data in is high, it will go to S4, ma'am, or else it will go to, or else it will go to S0 state, ma'am.
You have written something else for both the one input. You have sending it to S4 and S1.
No, no, that is not negative. Right.
Your voice is slow, like
if that is not negation, ma'am. If DN is high, ma'am, that should be corrected.
I'm saying about the S3. If the input is 1, you are sending it to both S1 and S4.
I'm saying from S3 state, if
Yeah,
my data input is high, it will go to S4. From S3 to S4.
yeah.
If data in is low, it will remain in the, sorry, it will go to S3, ma'am. Sorry, it will go to S0 ideal state.
Yeah, okay.
Uh,
So please correct in your diagram.
S ma'am, correct.
Okay. After that,
After that, from S4, if my data in is high, it is going to S5, ma'am.
yeah.
And if it is 0, it is going back to ideal state, ma'am. That should be correct in diagram. I have considered non-overlapping case, ma'am. If from S5 the output is fulfilled 11011, uh, and then if it is 0, it is going back to ideal state as 0, and it is 1, it will be for
Okay.
S1.
Okay. That's correct. But you have done the two mistakes.
Yes, ma'am. Yes, ma'am.
Okay.
Yes, ma'am.
Yeah. According. Okay. So your very low code, the framework is correct, and you can like just check the states by yourself. Okay.
That S3 state I will correct it, ma'am. Apart from
Yeah.
that,
Okay.
I will.
So I've corrected your state diagram. Okay. So according to it, you can like just correct your Verilog code. Okay, Praveen, have you done? You are mute. You are muted.
Ma'am, instead of more, I make melee code. Is it okay? Or I have to make at last I saw it is more.
Okay, show me the melee.
Okay. Should I say share my screen?
Yeah, you can.
Like I I took wrong data also. Now I only checked 1101 I took that I had to take 1101 I should take. But this is non-overlapping case. Melee I made and this for that I have to take 5 stage I have to take. So like for the 1101, like whenever it will one, it will come, then it will go to next state S1. Another one, then will go to another state S2. When it will come 0, then I gave this variable also P3 at each stage so that we can uh, go to next state easily by if condition. And when it will be 0, P3 0, then it will go to S3. And for next stage, we have to keep 1, then it will reach S4. And so after S4, we can go to the idle state S0.
Can you repeat?
Like these are one this code like at 1
Yeah,
1
okay.
0 and 1.
Please start from S
I am
node.
going.
Please
Yes,
start.
I am S node. When I'm at S node at 1 P1 equal to 1, then I'm going to reach S1.
Okay, okay, wait.
And
Okay, Hari. You also have to listen and check whether it is correct or not at the last. Okay. So Praveen,
yes, ma'am.
start.
Yes, ma'am. Like at the P1, when it is 1, then it is going to S1. And when P1 is 0, it is at S naught because I have to make 1 1 0 1. So for this
Okay.
one, I have to write like this. And for the when in the S1 state, when P2 will be 0, then it will be on S1 only. And for the when P2 will be 1, then we will reach S2 because we need 1. So we have to process for 1 only. And for the S3, and I kept P3 variable
For
when it will
S1,
be
is it correct?
for S1. Like
Yes.
one we needed now. So here one we are moving forward. After that we will reach at 1. It is
No,
0
but
output
at
0.
for S1, if
Yes.
the input is 0, then it should go to the S naught.
Uh, that is our choice. That is our choice. We can go backward also, but it is non-overlapping case. So uh, should I go backward?
Hello, ma'am.
Yes.
Actually, sorry to interrupt, ma'am.
Yes.
This is 1101, ma'am. He considered. Uh, it should be only 4 states, ma'am, for melee FSM.
Yeah, that's correct.
No, 5 because uh, this is 4, but we need one extra state to so done. Like otherwise, S3 will directly will reach to S node. So done state for done state, we have to keep one extra bit, one extra state we have to take S4.
Mm.
That's why I had to take in my code. Earlier I made with uh, 2 flip flop, but after that I had to change 3 because
Okay,
for the
Hari.
done state, uh, I
Okay,
needed one
Hari. Can
extra
you
state.
explain to him like why we need
Okay.
only 4 states?
Okay. Actually, it's good to meet you, Praveen.
Yes.
The thing is, in the FSM you're considering here is it belongs to More actually. The I am telling this based on a number of states, not on how you given that input output values. Because it can go to S1, S2, S3. It can go to S4 to S1 directly in Melee FSM. Because the output depends both on present state and inputs. It does not depend solely on present state. Uh, so yeah, in Mule overlapping, the S4 can directly go to S1 before explanation is for Mule actually. So for meal FSM, it will be only for n bit. It will be only n state. But for more FSM, it will be n plus one state if we consider n bit. Accordingly, have to think that's it.
So I need 4 states only.
Yeah, 4
Yeah.
states is enough for me.
After S3, where should I go? S1, S node.
After S4, you should consider whether it goes to S1 or whether it goes to whatever bits you have provided. It will go to S4 if it is 0 because 1101 0 it won't sequence won't start. If it is 1 it will go to S2 because sequence will start from S2.
Okay, so why the Mile's number of states are less than the Moore's number of state in finite state machine?
Uh, because ma'am, MILFSM it does not holds its value for it will hold value for both present state and input, ma'am. It will wait and accordingly it will give the output, ma'am. But when it comes to more FSM, directly it will give output. So we need one extra state for more FSM, ma'am.
Okay.
Ma'am, should I show my code?
First correct your state diagram.
Okay, ma'am. Ma'am, can you see my print? This paint?
Yeah.
Can you see?
No, paint. No.
Okay. Now you can see.
Yes.
Can you help with that? Where I should keep this one?
After the S3 state, if the input will be 0, it will go to the S0.
At like P4 it's 0, then it is 0 only. Huh?
Yeah.
And but
And
when
for
P1 is equal to 1,
1,
then it should
go to the
reach to
0, S
uh,
not only.
S not only. Like where is done state, then state need not require. Like it will work.
No, it will be like at S not only.
Okay.
It will like input and output 1, then it will go to the S not.
Okay. Okay. I will change in the code also. And I need to take only 2-bit here.
Okay, Hari, check the code also.
Can you see my code?
Yes, I am able to see. Hari, please check the code also.
Only last line I have to change. Like S4, instead of S4, it will reach S node. And at this S3 only. And like for the output state, then where I should write Like for the read, for the output state equal to S node. Which one I will try to?
Adi, tell please. Your voice is not audible.
Hello, ma'am.
Yes, yes. No, I can listen you.
Okay, ma'am. No, actually here the output logic means at what state the output became high. That is the state you have to consider here.
What you are saying?
Here output is high na ma'am. At particular state output will be high na ma'am.
Yes.
That is the state which should be considered in output logic. Actually it is 110 1. Next state is given in the here at S3 state if can go back to the first. Okay. If data in is high, it is going to S0. I think it should go to S1. Data
It's
in
not.
is
It's not.
Which one? On which state?
S3 state.
S3 state. Yes. When I am taking P4, it's 0. Then it is S3. P4 0, then it is going S3.
No, no,
And
no. When the input
P4
and
is 1,
output are 0, then
S0.
it will go to S naught only.
Yes, ma'am. That is
Praveen?
Yes, ma'am.
I'm saying that if the input and output are 0, then it will go to the S naught only. From S3 to S naught.
S3 to S0. Yes, ma'am.
Yes.
It is
0, 0/0. Right
0
there.
slash 0. Here I should write, huh?
no, no.
No, 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 no. What I'm trying to say that you have created the P4 condition, right? Where
Yes,
you have
ma'am.
at S3. See
S3.
at S3, you have
Yes, ma'am.
created the P4 condition for input and output 0. It will remain at the S3 only, but it will go to the S naught. I'm trying to say that.
Yes, ma'am. At this condition, when it's P is equal to 1, then it is going S naught now. Then if P is equal to 1, then next state will be the S naught now, ma'am. Else it will reach there. What you want to say here? What should I write?
Ma'am, can I
Uh,
attend?
yeah, please.
Actually, the thing is in S3 state,
Yes.
you considered P1, P2, P3, P4 na? Like that I think it's not necessary. You can consider only one data or P1 or P or anything one you can consider. That itself, if it is low, it is going to next state. If it is high, it is going to next state. That will be decided by only one bit. But you are considered P1, P2, P3, P4. That is four different bits. Okay, and from S3 state. Okay, accordingly, I will tell accordingly what we have written in this code. Okay. Uh,
Okay.
in S3 state, what you are trying to tell is if P4 is high, that is one bit high, it should go to it should go to what? It should go to the bit from which the sequence should start. That is S1. If it is low, it should go to S0 itself.
You didn't get on for which state you told? Like you are saying that I should not use conditional statement. I can use now with that also. But if I write that one, then what you said, I have to do, what I have to improve?
Okay. If it is high, it should go to next state is what? So accordingly, we have written next state is what from S3. It is if P4 is high, you are going to S0, na?
Yes, sir.
Okay, next year FSM. If it is low, then where it is going?
S3. P4 is low 0, then it is going S3 only.
No, no. What's that? We are trying to say that it will go to the S naught.
S node.
Yes.
S node is going when one is there, then it is
No,
going to S node.
for both 0 0 and 1 1. It will go to the
Okay.
S naught only.
Okay. Then these also I should change this one. These should S1 or it also goes to S node. These all.
No,
Okay.
no. For you have written that P2, right?
Yes, sir.
When the input and output are 0, it will go to S naught only. You have wrong there. From S1 to S naught, when the input and output are 0, it will go to the S naught.
Okay. Yes, sir. Zero by zero. Okay. And this I should remove. This also I should remove. This S1, S2 one. This also will go reach to ideal condition only. S node.
No, that is correct.
Here I wrote P2. P2 equal to 0, then it will status. P3 is
After the
equal to
session, you can like just
okay, I will try.
check
Yes, sir. Yes, yes,
and uh,
yes, ma'am. Well, just I have doubt in this. For the output, what I have to assign? Like S node
you
I have to
don't
assign
need it, I
state
think.
equal to.
There is no need to assign the output.
Yeah, there's no need.
Okay, okay, okay. Thanks, sir. Thanks.
Okay.
Should I stop my screen?
Yes. What will be the output of the question?
Hello, ma'am.
Yes.
Uh, at zero simulation time, both are zeros, ma'am. X0 and Y0. After the operation, X will be 1, ma'am. Still, Y will be 0 only, ma'am, because it is blocking a sentence. Oh, sorry, Y will be 1, ma'am. Directly, X value will be assigned to Y.
Wait. I'm not able to understand.
X value will be 1 and y value will be 1 more.
Why?
Because fork join it uh, left side statement will be directly assigned to the right side now because it is not non-blocking assignment.
Okay,
So
so Praveen,
Yes, ma'am.
can you like say whether Hari's answer is correct or not and why?
No, ma'am. I think X value he is telling correct, but Y value should be 0 because uh, for can join all statements works in parallel. When Y will process at that time, its value will be the 0 only. It it doesn't work in sequential. Okay, so uh, like it uh, because display also it is reaching asking at 0 only na. So we have to all things we have to calculate time is time 0 only. So x equal to 1 and y equal to 0 only.
Yeah, there can be a race condition like it if the simulator will first exit thread 1, then the answer would be different, and if the simulator will execute thread 2, then answer would be different. Okay.
Yes,
but actually if the simulation time is given, the answer will be changed.
Yeah, but there is no given simulation time, so it will execute parallelly.
Concurrent.
ma'am, if delay equal to y 1 at before y equal to x, then answer what will be?
Wait, what?
If delay 1 is given y before y equal to x statement, then
Okay. Honey, you are not audible.
Hello, ma'am.
Yeah, okay. So, what I was trying to say that if we will give a delay of 1 second before y is equal to x, you are trying to say that only, right?
yes, ma'am, yes, ma'am.
So the answer would be x is equal to 1 and y is equal to 1. Okay.
That's what, ma'am. Actually, that's what I thought, ma'am. Before, since no simulation time is given, I thought it will be 1, and accordingly, I said 1 1.
Okay.
Okay, ma'am.
That's what I'm trying to tell before.
Okay. But like if no time is
No
given,
time
so
is given.
we cannot consider by ourselves. So Praveen, you know about the assertions.
Yes, ma'am. Like
What are the
in the
assertions?
set of the inputs that we give so that we can verify the output. And uh, yes,
What
ma'am.
are the main purpose of
To
assertions?
verify the functionality uh, for the module, to verify the functionality.
So what will be the difference between the assertion and coverage?
Uh, that I don't know.
What?
That I don't know. Coverage, I don't know.
Okay. So, Hari, can you explain difference between the two?
Okay, ma'am. Sessions are nothing but those can be considered conditional sessions, because sessions are mainly for debugging, and yeah, the difference between them is coverage is code coverage and functional coverage. Those explains how often our statement got executed, and it explains what's the perfect functionality of the design. But when it comes to sessions, sessions, if we want to check our statement according to our given condition, if we if we want to execute our statements in particular way that if condition is met, my statement got executed, or else display statement won't be in sessions, ma'am. Else part won't be there in session. Coverage part is completely different, but it is for it is for I mean, the functionality of the design, it is for debugging.
Okay. What will be the output of this question? Um, if you know the answer, write it in the chat box. Hari, are you able to see the new chat option there and in the chat box? So you can select my private message and you can just send the answer privately.
I see only folk join question, ma'am. Is there any question other than that?
Okay.
X equal to 1, y
What? Uh,
x equal to 1 and y equal to 1.
wait. Please show privately answer. Okay, what you have said? X is equal to?
Me,
Hari? Okay, Hari, what you have said? No, X and Y will be printed once only.
sorry, ma'am.
X and Y values will be printed once only.
Yes, ma'am. I think that is. My answer is right or wrong, ma'am.
What will be the final answer I want to know?
X and Y are ones, ma'am.
No, that's not correct.
X equal to 1, Y should be 0.
Yeah, that's correct.
But after 15 nanoseconds, it will take the value of x num, that y value.
Can you explain him, Praveen?
Yes, like you can see that what happens in the third line. It is intra delay statement. Okay, so like after 5 delay unit only, x will be 1. Okay, because it will assign 1 only when after delay only, whatever delay is there, after that only, before its value is x equal to 0. Okay, so
Okay.
so what, and this statement works only at x equal to 0 only. Okay, so at x equal to 0, y will be 0. Okay,
Now for after
uh,
what simulation time x will be 1 and y will be 0.
after 5, x will be 1. Okay, but y will be because this statement works at x equal to 0 only. Okay, so y equal to 0 and x will be 1. Okay,
Okay,
and
so at 5 nanoseconds, the x will be 1 after the 5 time units. Okay,
Okay.
and at time 0, x will be still 0.
no, I ma'am, after 5, x will be 1 now.
Yes, yes, but I'm
Yes,
trying to
ma'am.
say that
So,
x will be 1 after the 5 units.
That I have mentioned in my answer, ma'am. But
Then after that, the non-blocking assignment is there.
yes, ma'am.
Okay.
In display statement, it will be after 10 nanoseconds, ma'am. 10 time units. My x value will be 1, ma'am, after 10 time units.
Yeah, after the delay, x will be 1 and y will remain 0.
Okay, okay.
X will get updated 0 to 1 because of the
Statement delay.
and y will not change because it's already scheduled to the y is equal to 0.
Okay, ma'am. Okay, ma'am. So my final answer will be after 10 nanoseconds, x will be 1, y will be 0.
X will be 1 and y will be 0.
Okay, ma'am.
Okay, okay. I think that's all from my side.
and in the
And
CMOS, what they can ask you, like related to the device, what they can ask questions.
in CMOS,
Like I have interview on first in the TI or digital role, and so people are asking that they may ask anything, uh,
they can like simply
temperature,
ask the why CMOS user inverter.
no, any temperature relation with the CMOS, like if temperature increase, what
Yeah,
device
yeah,
prefer
and
to.
pull up, pull down. You know about that
Yes, ma'am.
pull up, pull down, voltage transfer characteristics,
Yes, ma'am.
and the circuit diagram of CMOS.
No, MOSFET actually, MOSFET I want to ask, not CMOS, MOSFET, uh, like
MOSFET you're
with,
talking about.
yes, yes, one question from my uh, senior, they asked like if we increase, like one chip is there, if we increase the temperature, uh, then what will happen?
You
Uh,
want do you want to know the process variations?
yes, yes.
Uh,
In that related, what question they can ask to?
Actually, there will be. Ma'am, can I speak, ma'am?
Yeah, okay.
Actually, there will be subthreshold regions and cells, and the functionality of cells according to temperature they can ask. Even though you are going for digital role, they will ask you RC circuit, about RC circuits, ADM.
Yeah, so you were talking about the effects of temperature increase on MOSFET, right?
Yes, ma'am. Yes, ma'am. Like
Um,
especially they asked like if temperature, like this country's temperature is this. In the laptop there are ICs.
uh,
If we same laptop we go to another country, there will be temperature less. So what will affect to that chip? Something they asked
there
like
can be a change in threshold voltage, carrier mobility, ID. Like the threshold voltage can decrease slightly with the temperature. As the you know about the intrinsic carrier,
yes, ma'am. Yes.
intrinsic and extrinsic. So when there is an increase in intrinsic carrier concentration in the channel, it make easier to turn on the MOSFET. So you can just learn these concepts.
Okay.
Have you understood what I am trying to say?
Yes, ma'am. You are saying that threshold if we decrease, threshold will decrease if the temperature will be less. Threshold will decrease. Huh?
If the temperature will increase, then the threshold will slightly decrease.
Okay.
And the drain current part is very important. Like
Yes.
the lower VATH, it tends to increase the current, and with lower mobility, it tends to decrease the current.
Okay.
Okay.
Yes.
So, any other questions?
Mhm.
Praveen, any other questions?
FIFO, what question they can ask? FIFO,
FIFO depth is a very common question. Calculation of FIFO depth.
like which type question will be can you?
Calculating the depth of a FIFO.
Okay, okay. That just there will be row and okay, that yes.
Yeah, and asynchronous FIFO and synchronous FIFO. So asynchronous, they can ask many questions like why we use the gray code and all. You should learn the diagram of the asynchronous FIFO.
Yes, that I know.
Yeah.
And
Okay. Okay. Any other questions?
it's empty full condition. I know, and FIFO depth I will that I can calculate.
Yeah. Okay.
Yes,
You can
and
practice the FIFO depth question from the internet,
yes, ma'am, yes,
and
ma'am.
also you can like just learn the asynchronous FIFO things.
Yes, ma'am.
Okay.
Okay, yes, ma'am. Ma'am, in the ASIC flow design, we have to tell just like first what we take the requirement, what specification we select. After that architecture we make. After that RTL we made. After that synthesis. After that logic equalization, and after that we
Yeah.
generate
Okay. So
net
you, do you know
net
about
list.
the you do know about the abstraction levels?
Yes, ma'am. Like
So you can explain that also. In that
okay,
that would be like better.
like system. After that, we go chip level. After
Yeah.
that, we go gate
What are
level.
the
Then
higher
transistor
levels
level.
and lower
Yes,
levels of
yes,
abstraction?
yes. Okay.
Yeah.
Yes.
Sorry. So any other questions? You are not audible.
Like
Hello, ma'am.
हाँ जी, हाँ जी.
Hello.
हाँ जी, हाँ जी.
I think I asked about the referral, ma'am, before the last session.
Yeah, he was saying that like I have discussed it with the sir. So he has that he will refer soon when the openings when the company will open their openings in the design verification field, because we haven't the companies have not opened the uh, design verification openings yet.
Okay, okay, ma'am.
Okay, so
and
they
for the yes.
okay, okay, what?
Like ma'am, what input and output require in the physical design? Like what we gave input,
What
like physical for physical design process. Like what is the input required at the
input means?
like input files we need na some at the physical time, physical design time, like library file, LEF file, RTL, STC, netlist. Uh,
Referring to STA or
like when
Yeah,
physical
net list is
uh,
required. Input file, net list, library, and the floor plan like TCL files
yes, yes,
is required.
mainly netlist and library file and layer exchange file, LEF file we need na only, or input. Uh,
Yeah,
yes,
TCL
TCL,
file also.
TCL, yes, sir,
Yes,
TCL file
TCL.
is for the reference. Yes, yes. Okay.
Yeah, for the output it can be like
GDS,
RPT,
yes, yes,
GDS,
yes,
yes, GDS.
yes. GDS2 file we will get and yes, like synthesis input, synthesis for the synthesis process. What will be the input and output? Uh, like RTL code we gave input and we gave HTC file as input and library file we gave three input we gave only no for the synthesis.
Yeah, RTL file that will be dot V represented by dot V.
Yes,
Very
ma'am.
in the RTL code we always write it in a Verilog form, right?
Yes, ma'am. Yes, ma'am.
Okay, so constraint files. There can be constraint files and libraries,
Yes, yes, ma'am.
the IP blocks.
Yeah, ma'am. And at the output, what we will get to net list.
Gate level netlist.
Yes, ma'am. And time area power report also we will get
I think
time
we will
Yes,
timing
also
yes.
I think we
timing
will
area.
also get reports na, ma'am.
RPT file.
Yes,
What?
I think we will also get reports na, ma'am.
yes,
Reports,
timing
yeah.
timing area and power.
Yeah,
Yes, that's what we will get.
okay. So any other questions?
No, ma'am. Thank you, ma'am. Thank you.
Okay, Hari.
Yes, ma'am. Thank you, ma'am. Regarding
Okay.
company only, that is the only question I have.
Yeah, okay. So we will like refer you when the openings will be there from the companies. Okay.
Okay, ma'am. Okay, ma'am.
Okay, thank
Okay.
you.
Okay. Thank
Ma'am,
you.
For
when can I have next mock interview, ma'am?
in next week,
Okay, okay, ma'am.
Okay.
Thank you, ma'am.
So till
Okay,
that
thank
you
you.
can like just practice the questions,
Okay, okay,
output questions. The output question will like build your knowledge more deeply.
okay, okay, ma'am.
Okay.
Okay.
Okay. Thank you.
Ma'am, can you wait 2 minutes, ma'am? Uh, can I share my screen? Like one of my friend sent uh, like his interview experience, and like can can you see that and can tell something?
Okay.
Can you see my screen?
Yes.
Yes, for the digital role, like they asked the timing waveform questions. Like here they gave A bar B waveform they gave, and output was A bar B circuit we made. Setup and whole time they asked FIFO and full form its purpose. Problem regarding FIFO. FIFO depth. Given constraint, FIFO depth would be finite, infinite. Initially, I thought I made mistake, but it was indeed the correct answer.
Okay.
This is given the constraint. Okay, they gave anything like FIFO. FIFO depth maybe infinite also. Maybe.
Yeah. Yeah. I think we don't have like we have other class also. So can you share the this document to me in the personal?
Okay, now
Um,
in here only.
no, in the WhatsApp. Okay,
WhatsApp.
I'm
Okay,
sharing the WhatsApp number with you.
yes, ma'am. Yes, ma'am. Sure.
And we can like discuss it after 2 to 3 hours.
Yes, ma'am. Yes, ma'am. Okay, ma'am. Thank you, ma'am. Yes,
Ma'am, can you share number to me also, ma'am? Because I also have few doubts regarding.
Okay, okay.
Chat box are given.
What?
In char, nothing, ma'am. Nothing.
Okay.
okay, ma'am. Thank you, ma'am.
So in the evening we can discuss like okay.
Okay, okay, ma'am. Okay. Thank you.
Okay, thank you.